Top 10 things that might have gone wrong with the Titan submersible. Starting us off at number 10, the hull. So we're going to start off with the most likely scenario, and that's the design of the hull. So obviously this ship was designed to go to incredibly deep depths. I don't know if you guys have seen the infographic that shows how deep the Titanic wreck is to the Empire State Building, but it's wild. However, at these depths, the ocean is exerting an intense amount of pressure, and so there's a theory that the design of the craft itself could have led to the implosion. What I mean by this is that although the Titan's composite hull should be built to withstand intense deep sea pressures, things, as we know, can go wrong, and so any defect in its shape or build could compromise its integrity, in which case a near instantaneous implosion would be the most likely thing to occur. Also, if you look at the rear of any other deep diving sub, you'll see that the tail section is relatively symmetrical. However, the tail of the Titan sub is curved upwards, which is highly unusual. And according to former Navy Captain Ryan Ramsey, when asked if the unusual design of the Titan was reckless, he said, "I wouldn't go so far as to say reckless, I would say disregarding standard ways of building these types of submersible in pursuit of innovation has huge elements of risk, and in this case, that risk has been realized in the loss of people's lives." Coming in at number 9, a short circuit. Another theory that has floated around is that a short circuit could be to blame. Essentially, if we accept that the tail of the hull were to have any kind of vulnerable point, it is possible that the interior electronics could get sprayed with water, which would likely cause a catastrophic short circuit and spark a fire inside the vessel itself. Now, if that is what happened, it would have created a multitude of issues. Firstly, there would be an immediate danger of toxic fumes, but it would also compromise the vehicle's electronic systems, which are used for navigation and control of the vessel. Or it could harm the propulsion, the life support, the emergency systems, and even the lights. Coming in at number 8, the door latch. While we're on the topic of design, the way that the Titan submersible was created, the only way out of the vessel was for it to be unbolted from the outside. So similarly to what we talked about surrounding the design of the hull, if there was any kind of malfunction surrounding the latch on the sub, it could also have allowed all of that intense pressure inside. According to Ryan Ramsey, quote, "The hatch with the 17 bolts they used to seal them in might have had a failure, which has then caused the hull to collapse at pressure because there is a huge amount of pressure even halfway down." So really, it all comes down to a potential defect that allows the pressure inside the vessel. Coming in at number 7, communication. Deep sea communications are a challenging endeavor even under the best of circumstances. And for the Titan sub, they opted to use a text messaging system which would send off instructions from the surface vessel in 15-minute increments. Now, I'm not going to remotely pretend like I know anything about this kind of stuff, but it is rumored that the sonar system they were using for navigation could have potentially not been of the best quality. So what that means is that the communication they would have been receiving could have potentially not been as accurate as one would hope. Plus, a lot can happen in 15 minutes, and some are wondering if they should have maybe considered shorter amounts of time between the check-ins. Again, I'm not an expert, and considering they lost all communication very quickly into the dive, there isn't much to go off. But in theory, it could have been one of the issues. Next up at number 6, the controller. I'm sure by now you've seen the controller that was guiding this multi-million-dollar craft through the deep seas, but in case you haven't, it essentially looks like your average, if not outdated, PlayStation controller with a few customizations. On the matter, Steve Wright, who's an associate professor of aerospace engineering at the University of the West of England, says several aircraft and sea vessels are partially controlled by what looks like a video game controller. But while a video game controller might have most of the capabilities as a regular joystick controller on a sub, Wright says it would definitely not be as reliable, and when shown a photo of the Titan's video game controller via email, Wright said he's, quote, "never seen anything like that, and expected there would have been a more reliable main system. Quote, "In fact, I would expect the real submersible controller to have a reliability of about 1,000 times that of the game's handset. I mean, I'll be honest, I have no sweet clue if this could have anything to do with it or not, but by the sounds of it, it may not have been the best choice. Coming in at number 5, the ballast system. The ballast system may differ from ship to ship, but the basics remain the same: filling, removing, and transferring water from one tank to another to get the required stability for a ship. Now, according to interviews in the case of the Titan submersible, these were 2 separate systems, with ballast needing to be physically dropped to allow the inflating air bladders to increase buoyancy. However, despite that it appears there were multiple ways to dispel the ballast even without electrical power, it is unknown what these systems were exactly, as the only evidence of control from within the sub were the video game controller and one single button. So considering the loss of communication, it's unclear if they would have been even able to drop the ballast independently in order to increase the buoyancy and send them up to the surface. Coming in at the number 4 spot, battery packs. So given that the Titan was a battery operated watercraft, it may have suffered a power failure. Now ideally there would have been an emergency backup power source to maintain emergency and life support equipment, but it's unclear if the vessel had any power backup on hand. And unfortunately, the batteries, like all the other critical systems, seem to be primarily housed in the glass fiber tail. So while the lithium-ion batteries are rechargeable, efficient, and able to store large amounts of power, they are also highly flammable and explosive, especially when exposed to water. So back to the potential vulnerability issues with the hull: if the batteries were stored in the hull and the hull became compromised, it would likely have contributed to the disaster. Coming in at our number 3 spot, it just wasn't ready. According to Professor Eric Fussell, an associate professor and director of the shipbuilding hub at the University of Adelaide, industry standards around submersibles can be vague given it's such a niche sector. And it wasn't too long ago that one man was questioning if this entire vessel was a good idea or not. Back in 2018, former director of OceanGate's marine operations, David Lockridge, questioned the ability of the tourist sub's hull design to withstand such depths and even filed a lawsuit saying that he was not confident with the experimental design of the hull. This of course did not go over very well, and OceanGate fired him and filed their own breach of contract suit against Mr. Lockridge, stating that he's not an engineer and that he refused to accept the lead engineer's assurances, and also accused him of improperly sharing confidential information. I can only imagine how that man is feeling now. Coming in our number 2 spot, unsuitable materials. Another theory about what could have caused the implosion is that the equipment and materials used were overall unsuitable for the depths they were going to reach. Former Marine Robert Mester, who actually declined going on a previous trip with OceanGate, said, quote, "They were using off-the-shelf hardware to operate inside, and quite frankly, we're talking about an environment that requires robust equipment that has certifications and qualifications that are established by different agencies for man-rated submersibles. None of the equipment that I saw inside the submersible was up to that level, so I just chose not to go." He then goes on to explain that the carbon fiber hull was particularly concerning, as it is apparently not a material that has ever been successfully used at great depths. And last up in our number 1 spot today, no outside regulations. Sort of in tandem with the point in reference to David Lockridge, the biggest concern was that the Titan wasn't properly regulated for safety. Pretty much as the Titan submersible operated in international waters, it was not subject to regulation by any country, including the US law that requires passenger submersibles to be registered with the Coast Guard. Now, this is not to say there were not concerns or even objections. In fact, members of the Marine Technology Society's Manned Underwater Vehicles Committee wrote a letter expressing a unanimous concern about the development of Titan, claiming it had not undergone a standard risk assessment and emphasizing the importance of third-party validation to ensure the safety of submersible occupants. But still, OceanGate defended its decisions, stating that its goal was to pursue innovative design and operation outside of the established system. system. Now, this is a concern for several reasons, one being that the Titan was not solely a research vessel, but was actually designed to be a commercial vehicle to facilitate profitable Titanic expeditions as well. But it is also curious why they wouldn't want to ensure every possible safety measure they could.